In this video, I want to talk about the idea of existence proofs. And these, well, it's kind of in the name what they are. Rather than showing something is true for all values, you're asked to show it's true for at least one. So that's kind of all there is to it. You just have to find a value that works. So let me do one that's quite easy just to show you the logic of what's happening. And then we'll do one that's a little more complicated, just so you can see that not all existence proofs are easy. And this one will be quite hard, in fact, but I'll tell you how to think about it. So let's start with the first one. First one is kind of one of the easiest things that we can do. Show that there's an integer n such that the square equals its cube. So we need to find an n such that if you square it, it's the same thing as if you cube it. And this is a very easy example in some sense. I'm sure right off the bat you're thinking of one or even two integers where this is true. We only need one though. It says show that there is, so that means, or I should say there is an integer, so there is one integer. So our proof is just to find that one and show it works. So the one that I immediately see is 0. 0 multiplied by itself any number of times is still 0. So let n equals 0. Then let's write it in fact like this. Then 0 squared is the same thing as, of course, 0, and that equals 0 cubed. And that's it. We've done it. We've completed this existence proof. We found an object that satisfies what we want it to. So that one was quite easy. This one's a little more difficult. So we want to show that there's two irrational numbers, a and b, such that if I raise one to the power of the other, I get a rational number. So that's pretty interesting. The way I'm thinking about this is, well, one way I know to kind of simplify irrational numbers to rational numbers is I know something along the lines of square root n times square root n is n. So if you're picking a non-square number, something like square root 2, maybe this fact here will help us out. So let's go ahead and kind of explore. So my first thought will be something along the lines of, well, let's try square root 2, because that's kind of easy to think about, to the square root 2. But I can't say whether it's rational or irrational. That to me is quite hard to simplify. So this is either rational or irrational. Well, if it's rational, if it just happens to be rational, I would be done. Okay, but maybe it's irrational. And you could think, well, I don't know, maybe that's bad. But maybe I can use this irrational number as one of the a's or b's here. And then, in that case, well, maybe I can do something with that. So let's say that the base was this square root 2 to square root 2. And I know I can raise this whole thing to the power of square root 2 again. And thinking, I know that a power of a power, well, you just multiply powers, and now I can use this fact. So that is pretty cool. And we could think about how to simplify this. Square root 2 times square root 2 is going to be 2. So we're going to have square root 2 squared. And square root 2 squared is just 2. And that is rational. So it looks like we kind of have two options here. So let's do a proof. So let's consider square root 2 to the power of square root 2. And there's two cases here. So the first case is that this expression just happens to be rational. We don't know, but it could be. Case 1 is that square root 2 to the square root 2 is rational. And if this is the case, then let a be square root 2 and let b also be square root 2, and we're done. So if that happens to be rational, then we've done it. Case 2 is that it isn't. Square root 2 to the square root 2 is irrational. And in this case, then let a be square root 2 to the square root 2 and b be square root 2. We just need to show that this is indeed it simplifies to something rational. So let's do it then. Square root 2 to the square root 2 to the power of square root 2. That's our a to the power b. Well, that simplifies to square root 2 to the, well, if you have a power of a power, you just multiply powers. Square root 2 times square root 2, which is square root 2, and square root 2 times itself is, of course, just 2. That's the definition of a square root. And square root 2 squared, well, if you take something that's a square root and you square it, you just get the original thing. So you get 2. Maybe put some brackets here so it looks like I'm taking the whole thing, square root 2, and squaring it. And then we just need to say, since 2 is indeed a rational number, 2 over 1, we have found our a and b. And we're done. And this one is kind of interesting if you think about it, because we, at least a priori, don't know which case it is. Maybe this guy is rational, and we're done. But maybe it's not. But even if it's not, we still found our values. We just take a to be this number, and b to be square root 2. So either way, whether it's true or not, we still showed that we can find two irrational numbers where we can raise one to the power of the other and get a rational number. And that's how these proofs by existence work.